All right, so when it says find the maximum or minimum value of the function, when they say value like this, they mean one amount, okay? A lot of times when they're asking us to find the max or the min, or the local maximum, local minimum, a lot of times we write that as an ordered pair. Essentially here, they just want the y value. The y value that is providing us either the maximum or the minimum, okay? Now this is a parabola, okay, and that leading term is positive, so this parabola is going to be concave up. So it's going to be a maximum, correct? Oh, sorry, minimum. It's going to be a minimum, right? Does that make sense, everybody? So we can select that right away. But now how we find the minimum, you can do one of two things. You can go through and complete the square and find the x coordinate of the vertex and then plug that in to find the y value that goes with that. But I think what's going to be more beneficial for you is just to remember that the x value of your vertex is located at opposite b over 2a. Okay? So this is the x value of vertex. Okay? So plugging that in, so then I get x is equal to negative 16 all over 2a, which would be 4, so at negative 4. So the x coordinate of my vertex occurs at negative 4. That's where my maximum or my minimum will occur as well, okay? But this is not the value that we use to describe our maximum minimum. We use the y value, okay? So I'm going to find what f of negative 4 is. This would be 2 times negative 4 squared plus 16 times negative 4 and then minus 5, okay? So the 4 squared is 16 times 2 is 32. Minus then, this is going to give me 64. And then minus 5. That should give me negative 37 then as my y value. So what that tells me is that my minimum occurs at an x value of negative 4, so 4 over in that direction, and then down negative 37. Okay? So my curve is going to look something like that. Does that make sense? Concave up. If the goal was to rewrite, now that I've got this information, guys, if the goal was to rewrite my function in vertex form, we could do that. We could say that, because remember, if I'm here at negative 4, negative 37, if I've got the function f of x is equal to some a times x minus or plus, how do you want to write that, h squared plus k, well, this is a. Okay, so now if I go from 0, so remember it's a parabola, so this point here is corresponding to that point there on the parent function, so it's moved left 4 units, right? So this would be plus 4 there. We would square that, okay? And then we move down 37, so that would be minus 37. Is that right, everybody? Okay. Now, that would not match if I factored that out, okay? Or FOIL that out, sorry. Let's see what that would look like. I'm just going to cheat here. If I just ask this thing to expand x, I need to set parentheses, x plus 4 squared minus 37, you see that that gives me x squared plus 8x minus 21, which is not this thing, right? So what do I need here in front to change an x squared to a 2x squared? I need a 2, right? And that's going to change the 8x to 16x, okay? And that's going to take care of these two things. And it's just order of operations, ultimately, guys, that's going to make this negative 21 turn into a negative 5. Because when I put a 2 right here, order of operations says do that expansion first. Okay, so you get x squared plus 8x plus 16. Then you double that, and then you will subtract the 37. So you've got some, well, you got 32 in here when you double that 16 that you get from your L times your L, your last times last, and then subtracting 36 will then give me the 5 I need now. I don't know. Maybe I got to put my multiplication in here. There we go. What you're trying to use, so this is called a computer algebra system, computer algebra solver. When you're using that type of thing, I put that 2 in there, and it doesn't, well, I guess it did there. Well, and I think it's just because, let's see if it's Control V. Oh, it did work. Sometimes it won't understand implied multiplication. Sometimes you got to put in, just depending on what program you're using, you might have to put in the multiplication sign. But you see then that RA, change it to 2, we'll indeed get that thing then in vertex form. Now you didn't have to do that obviously on this question, but once you have what the maximum or minimum is, and your goal is to get into that form, it's pretty quick to do that. Is that all right, everybody? Okay. So doing 12 then, same idea. Okay. Now the only thing with 12 then, and it's something we won't pay attention to in all of our functions, everything that we deal with that is polynomial, we're going to rewrite this so it's in descending order. So negative x squared minus 8x plus 5. All right. So now this thing is, my a term is negative 1. So this thing is going to be concave down. So that's why we've got a maximum. Okay, that point right there, that vertex is going to be a maximum. So when we say x is equal to the opposite of b or 2a, so the opposite of b would be 8. 2a would be, what, negative 2. So again, I'm going to get negative 4 as my x coordinate of my vertex. Evaluate then f of negative 4. So it's going to be, now here's where you got to be cautious. That negative right there needs to be there. Negative 4 is what we're substituting in for x. Okay, so I need a negative 4 in parentheses. Square that. Minus 8 times negative 4 plus then 5. Now order of operation says it's going to be 16, but you negate it, so it gives me negative 16. This is only going to be positive 32, right? And then plus 5. So there's where we get, so this here gives me 16 plus 5, which is 21 then. And that's what we're looking for. Is that all right? Just kind of want to show you the quickness of this. Once I have that stuff, going into this format, f of x equals a times x plus h squared plus k, pretty quick. I've got my a, my x, okay, my vertex is at negative 4, so it becomes plus 4. It's at positive 21, so it becomes plus 21. My a, I need this a, if I FOILed that out, that would be a positive, so I need a to be a negative 1. And now I've rewritten that thing in vertex form, and I think that's a quicker technique or a quicker approach of finding the vertex form than using the complete the square method. Okay. Ultimately, I think we proved in class a couple days ago that they're the same thing. The x equals opposite of b over 2a is generated through the process of completing the square. And the h and k are just kind of redefining that argument. Okay, so basically when we complete the square, this thing right here where my cursor is turned into b over 2a. All right, so just redefining that as h allows us to come up with that little formula, x equals opposite b over 2a. I think those are, in regards to maybe some things that you're going to see in the future, just kind of going off of memory, the chapter test or section test for this does have questions like that and asks you to find the maximum minimum, and actually convert something like this into vertex form and so forth. So those are good questions to look at. Are there any others on here that you guys wanted to talk about or struggle with maybe? Feel okay with being able to do this type of stuff here? Okay. And this is kind of, guys, the breakdown. This is just, I said last week, it's kind of a snapshot of what we're going to do ultimately for all of our functions that we see throughout the course. All right. This thing here is pretty important for all the functions we're going to see. Y-intercepts are going to be pretty important. And what we started talking about yesterday in behavior is going to be a huge aspect of the remaining functions that we have to talk about. So that's one.